Hello and welcome to another advanced skeleton video. This time we're gonna look at some advanced deformation techniques. And for this we're gonna use this lovely character, which have been modeled by the legendary artist Stahlberg. And there's a link below where you can see more of Steven's beautiful artwork. And we'll start out as per usual by importing a fit skeleton template and match it to the character. And we'll go ahead and use the geometry snapping, which is snapping the locators to the center of the mesh. Now, note that the center of mesh snapping works faster if you turn off geometry selectable. Now we can see for this arm it's actually ended up rotating slightly downwards. Now the rotation of the arm is automatically determined by the plane of the shoulder, elbow and wrist. So to make this elbow point more straight backwards, we could simply move the elbow joint position up ever so slightly. And we'll go ahead and build the advanced skeleton. And let's start out with looking at the deformation of the arm. First we'll apply basic skin weights using the skin cage. The skin cage is a good place to start your deformations. It is a automatically generated polygon cage built from profiles at every joints and scales taken from your fit skeleton locators. The skin cage is also automatically bound to the skeleton. However, the distribution of the edge loop in this polygonal cage will be in many limbs, as of here, defined by your distribution of twist joints, which means in, for example, this elbow, the start and the end of the deformation is determined by the distance to the nearest twist joint. This might not always give the best results, so we're going to have a look at a function in the advanced section called move the red skin curves to deformation width. So what does that mean? Well, we have these green curves at the major joints, such as the elbow, and then we have the red curves, which here is lined up with every twist joint. Now each of these curves are essentially profiles that are directly driving the edge loops. Let's go ahead and give that a try. So what happened was all the red curves moved. Okay, I'm gonna undo and redo so we can do a comparison. This is before we have an even distribution of the red curves between the green curves, as these are placed by the twist joints. As I hit redo, we go back to the refined placement where the skin curves are matched to the deformation width. Now the deformation width is the average size of the deformation on the two other axes. So for the elbow, the deformation width is an average of this distance, and that result is determining the new position for the red curves. And by doing this, we're going to get a better deformation result. And at this point, we're going to use the copy weight functions to transfer these weights over to our geometry. Now we'll take off this glove for a minute and just focus on the deformation of the skin of the elbow. And now we're going to start doing some tricks. Now we'll take this geometry, we'll duplicate it. I'll unparent this duplicated mesh so I can easily keep track of it in the outliner, and I'll give this a unique name and put it on a separate layer. And now we have two skins. Here we have our original geometry deformed by a skin cluster, and on layer 1 we have the newly duplicated geometry with no deformations yet. Now what we're about to do is set up some more advanced deformation on this duplicated skin, after which we're going to transfer that deformation onto our original skin. So let's set up our advanced deformation. We'll start off with a skin cage, and we'll move red skin curves to deformation width, and we're going to apply slider joints at each of these profile curves and generate a subwrap cage in the option tree section. Now, if we're having a closer look at the deformation of this subwrap cage, it's deforming quite nicely and doing a good job at preserving volume. So we're gonna get this deformation across to our duplicated mesh by using the wrap selected mesh function. And we got a much nicer deforming elbow. Now this setup itself could be fine for some projects, however if your production requires many characters to be in the same shot, the resource-hungry wrap deformer is going to end up slowing down the frame rate too much. So what we're going to do here is essentially bake this nice but resource-hungry deformation into much less resource-hungry corrective blend shapes. And that's why we kept our original geometry separate. Let's first do a comparison of the two before we transfer any deformation. This is our advanced deformation mesh, and there's the original one. So we're gonna go down into the corrective shapes section and open the advanced tab. And where it says bake deformations to corrective shapes, we're gonna choose a source and a destination mesh. Now this one with the nicer bend is our source, and our original mesh is the destination. For now we'll only transfer the required rotation, which is the positive Z. And make sure we select the FK controller representing the joint where we want to transfer deformation, and hit bake. And there we go, we have the much nicer deformation on our much faster original mesh. And we can see that this is indeed a corrective shape, as we can dial the envelope in and out. Note the deformation is not going to be identical to your sub-wrap deformation, as the corrective shape bake function essentially just generates one mesh at 90 degrees for each of the selected angles. However, this principle can be applied for any custom deformation to be baked into simpler correctives. And now to tidy this up, we would make sure to clean out the resource-hungry advanced deformation. So we'll delete the sub-wrap, we'll delete the skin cage, and delete our advanced deform mesh. And we're left with our original mesh, which performs quite well with only a skin cluster and a corrective shape. And we're getting our new deformation. Now that's it for now. Hopefully this has shown you some of the deformation options in Advanced Skeleton. And we'll finish off with putting our lovely character in a walk designer cycle.